Except, this is the potential code that could bring an error, and this is how you want to manage the error. If you catch value error, it means that the person has put an invalid number. Invalid input, please enter a number. You have caught this particular error. Value error is common because it's a potential with the code that you have here. Hello there, welcome to my YouTube channel. Today is the day 13 of my 15 days of Python series. Whoa, if you've made it this long up to day 13, I just really want to congratulate you because you're stuck from day 1 up to day 13, learning all the basics and fundamentals of Python. And today we're going to be looking at a very critical part of Python, which is error handling. You may ask the question, why are we handling error? Well, the computer system is a perfect system. It lives in an ideal world, meaning that in the human world, it's not an ideal world. You could make mistakes and people could correct you to say, you made this mistake. You could even make mistakes and everybody will carry along and just assume that you meant something else. But the computer world is a perfect world. If you're meant to put a parenthesis, you don't put a comma. And if you put a comma, you're going to have an error thrown at you. And when you're building a complicated system, you're building an application, you're trying to do data transformation, sometimes you just want to be very proactive in managing or handling your errors. You want to tell the computer system, I know that there's likelihood of having maybe syntax error here, error in number, invalid numbers, or whatever error. I just want to be proactive. I want to preempt you. This is the error message I want to get out. And if not, if you don't handle errors, your program is going to crash because Python runs in a sequence and the first part has to be completed before the second part has to go on. So we're going to be looking at understanding error handling, the try, except, else, and finally blocks. Secondly, we're going to be looking at catching specific errors and raising exceptions. How do we catch those specific errors? And of course, we'll be able to create our custom exceptions. We'll see how we could do that. And finally, we'll just get our hands dirty a little bit. Try and accept blocks and give you some exercise of your own that you could try, and we'll come back with the correction to see how we catch along. A basic introduction to error handling. Error handling is a crucial part of writing robust programs. What Python does, it provides mechanism to handle exceptions, errors that occur during the execution of a program. And it provides different mechanisms, which is what we're going to be covering in this video. But first, let me explain some of the errors that you typically have with Python. One popular one is called the syntax error. It is called syntax error because for whatever reason you didn't use the correct syntax when writing the code. In this example, it just throws more light on it. The correct syntax for using the print is to say print parenthesis and you put what you want to print, especially the string within quotation. But here, we omitted the last parenthesis, and because of that, we're going to be thrown a syntax error. So syntax error usually happens when there's inconsistency in the syntax that Python code is expecting from you. The second kind of error that you might have is the exceptions. And errors that occur during the execution of a program are called exceptions. Some of it is division by zero, file not found, and some of these are typical errors you could have. The division by zero is obvious. If you do 2 divided by 0, you're going to get a math error if you're using a calculator. And if you're working on Python, because it's not possible to do any number divided by 0, you're going to get the division by 0 error, which is a common error people have, especially when they're trying to do some mathematical calculations. They have the file not found, you put in a file that doesn't exist, you could have that error thrown. You could also have the value error and so on and so forth. Now, what is the mechanism that Python provides for treating or managing these errors? To handle exceptions, especially exceptions, you use the try and except blocks. Code that might raise an exception is placed in the try block, and code to handle the exception is placed in the except block. So this is it. The first one is the code that is likely to throw the error. It's just a potential error that could come from this code, and you put it in a try. And to handle the exception, you place the code in the except block. There's an example. We do 10 divided by 0. Of course, you're going to have a bunch of error that might be very, very complicated for you to even read, or your user or your end user to read, or even it's going to crash your program. But you won't need to continue. You could say, try this. If it doesn't work, except this is the error. If you catch this error, zero division error, if this is the error you catch, this is what you should print. Print cannot divide by 0. If you run this and you catch any error that has to do with zero division error, this is what you should print. And so what you've been able to do here is the code that is potentially likely to bring the error is put in the try, and the code you want to use to manage the error or what output you want to get, you put it in the except. Catching specific exception, this is like what we have in the previous slide, but just to give more examples. So you can catch specific exceptions by specifying the exception type after the except keyword. Here you are telling the user to input a number, and when you input the number, you say result is going to be equal to 10 divided by the number. Except this is the potential code that could bring an error, and this is how you want to manage the error. If you catch value error, it means that the person has put an invalid number. Invalid input, please enter a number. Probably instead of a number, the person put in a word or a string or a sentence or whatever. You just tell the person invalid input, please enter a number. You have caught this particular error. Value error is common because it's a potential with the code that you have here. And another one that you could have is the person providing 0. And 0, the zero division error, just like we see in the previous slide, is a potential error, and you could catch this exception. When you catch this exception, you provide a print statement to say cannot divide by 0. And the person knows, maybe I shouldn't be providing 0 here, I should be providing another number. So this is how you can catch specific exceptions within your code block. Again, like I explained, the try is where you put in your main code. All of the code that could potentially raise an error, and you come to the except block. There you manage what output you want to get, and you manage the exception that might be thrown from the try block. So we have another block called the else and finally blocks. The else block executes if the try block does not raise an exception. If you don't get any exception from the try block, the else is going to run. In this case, I have my main block here. This is the main code, and I just put in what I had previously, giving all of this error. If for any reason no error is thrown, the else is going to run. The result is the value gotten from here. Let's say the user enters 2. The else is going to print 5. But if the user enters 0, you're going to have this thrown. If the user enters a word, let's say the user writes car, you're going to have this thrown. Finally, the finally block executes regardless of whether an exception was raised or not. So this is going to run regardless. So whether you have an exception or you don't have exception, this is going to run, and that is the finally block. And in my case, I'm just saying execute complete regardless. I'm not telling you whether I'm not giving you what the output is, I'm just telling that this is executed. Now we've talked about how you can have exceptions within your code. But again, you might want to raise exceptions by yourself. You might be working on something and you say, well, if you do this, I want to raise an exception. In the case here, I'm just writing a function, I'm defining a function called divide. I give the function a name. The function is going to take 2 parameters, a and b. Here I'm saying if b is equal to 0, I'm going to raise an exception and say value error cannot divide by 0. And in this case, I have raised an exception myself. Instead of catching an exception, I could actually raise an exception. So when I define this function, I'm now going to call the function. In calling the function, I'm still going to put it in a try and except block. This is what I'm going to do. In my try block, remember we said that the try block is where you put in the main code that is likely to throw up an error. In the try block, I'm saying try result is equal to, I call my function that I've defined above. I do 10 and 0. Remember here, I put a condition that if b is equal to 0, raise this exception value error. And now I'm going to put my except block to catch the value error. My except block is going to catch the value error, and here, because my b is 0, is going to catch the value error. And what is it going to print? Is going to print the exception as e. It's going to print this and tell me cannot divide by 0. And this is how you catch. So you could raise your own exception, and later in the code, when you're trying to call the function, you could actually catch that exception and print the exception for the final user to know what they might be doing wrong. You could also create exceptions by inheriting from exception class. Well, we've not done anything on class, which is what we're going to be doing later on in this series. However, this is just to give an idea, and I'm not going to spend so much time on this because I've not spoken about it. But just to say that the same thing I did in the previous slide, I can create custom exceptions. I have my class negative number error, and I put that as an exception and I pass it. When I come to define a function, the function is square root. I give the function a name, and I put in if s is less than 0, you raise an exception. Here I've raised an exception and I give what the output should be, and this is what I want returned. I come back to call my function, put it in a try and except. Result is going to be the square root of -1 because the exception is going to be raised the moment x is less than 0. -1 is going to throw up this exception. However, I'm going to catch the exception. Setting up this to catch that exception, I'm going to print this to say that this is the exception that I've set to catch, and it's going to catch that. Now, we've said a lot about this. Sometimes this thing is more understood when we go practical and we get our hands dirty a bit. I'm going to be going over to my environment and let's see how we could get cracking. If you've not, you could go ahead and create your directory for day 13, and within that I'm going to create a new file called example1. And here I'm just going to write what we're going to do is division function with exception handling. It's just a division, just like the example that we had in our slide. I'll define a function to manage division, and I call this safe divide. It's going to take in two parameters, a and b, and I come here to say try, return a divided by b. This is what you should do. However, I want to catch an exception. The exception, I want to catch a specific exception called the zero division error. This is the exception I want to catch. And if for any reason you catch this exception, this is what you should return. Return this statement here, cannot divide by 0. Alright, so let's call our function now. In calling our function, I'm going to add the user to input for both a and b. I'm going to create a variable for float. For a, I'll create a variable for a, float input. For a, I tell the user to enter the numerator, and for b, I'm going to tell the user to enter the denominator. When I'm done, I'm going to print result, call my function a and b. Let's see. Let me enter the numerator as 2, denominator as maybe 5, I get 0.4. If I should run this again and I provide 5 and I provide 0, it's now going to look out for that particular exception, that particular error, and it's going to now return this, cannot divide by 0. Just to show you that because we did not provide any other exception for it to catch, if I enter an invalid number, I'm going to just get the program to crash because I did not take care of that exception. So let me run this now, and let's say I put in a word. The program will crash because I did not take care of the value error. Because I did not take care of the value error, the program is going to crash. But this is the only specific error that I'm trying to take care of, I'm trying to manage, and that is why I could only catch that. And now with this, you have an understanding of how you can manage specific errors when working with this. Our next example is to read file with exception handling. Just like what we say in the last example, we had a situation where we had other errors that we didn't take care of, and because of that, our program crashed. But in this exercise, in this example, we're going to be do a little more things to kind of manage general exceptions after we have defined the exceptions we want to catch in our program. Let's go over to our environment and see how we could do that. I'm going to create example 2. To read from a file and handle possible exceptions. I'll define a function. The function is to read file, and I'm going to provide a file name. The first is the try. We've done this already, how to manage files, so I won't explain so much on the code. I'm just gonna say wait open, file name, read as file, content is equal to file.read. I'll print the content of the file. However, if the try block does not work, how do I manage the exception? I'm going to say except a specific error I want to catch is file not found, which is a very popular one when you're working with files. File not found error. And I'm going to catch this and give it an alias as E. After that, I'm going to print. I'll use the formatted string because I want to add the exception. Say file not found E. I'm going to catch another one. I could just say except. Let me catch another one. Permission error. Probably there's some permission problem with the person trying to read the file. I could say permission error, and I want to catch this one again as E. And I'm going to print similar thing and just tell you straight up permission denied. I could stop here, but so I don't have the same scenario as the previous example where there were other errors thrown that I did not take care of for whatever reason. What I'm going to do is I'm just going to put a general exception to catch every other exception. And to do that, I'm going to add another except block. And I'm going to say exception as E. This will catch every other exception. But because I'm not so sure of what exception is going to catch, I'm just going to write like a generic statement. And I'm going to say use formatted string and just say, hey, an unexpected error occurred. And I'm going to put the exception so you know what was raised. And this handles every other exception that might be seen. Just put in one more R here. Okay, that takes care of it. Now let's try to read in our file. If we read in our file, I'm just going to call the function read file. Of course, I don't have any file here, and because I don't have any file, let me just put non-existent file to read. I just say non-existent file.txt. I don't have any file like this. Oh, sorry, non-existent. I don't have any file here to read. Let me run this. It tells me file not found error 2, no such file or directory, and this is what is being printed. So when I run that, this is what it shows, file not found. This is the error it caught, and you could see my print here, what I printed to say file not found. This is what it shows, and the E is the exception, and is now going to print in the exception, and this is the exception that came out. And you could try this and you can see that this handles all of the exceptions that I could have while running this. So in the exercise is saying write a Python script that reads a list of numbers from a file, calculates the average, and handles any potential error. This exercise is quite on the high side, but I just want you to be a bit more ambitious and try this on your own, and because it's going to have all of those exceptions, and there's no one way of doing this. You could have your own way of doing it, but essentially just to capture what the requirement of the exercise is. And I'm going to have this done on my own environment, just like a correction, and we could use this. I've taken the liberty to write out the code just so I could just focus on explaining and not rewriting everything again, and this code is going to be provided for you on the video description. But let me explain, and this is just trying to open up the try block, and I'm going to be defining a function called read numbers. The read numbers is going to be taking a parameter called the file path. It just provides the file path, you can see down here at the bottom, this is where I'm calling the particular function that I have. But before then, I'm going to provide the file part and provide a file called numbers.txt. At the moment, I don't have this file existing, and this is going to be quite interesting because you could see how some of these errors are going to evolve. And when I have the numbers, I'm going to read the numbers. I'm just going to call the function to read the numbers, and when I call the function to read the numbers, I'm going to call another function called calculate average. I'll call the function to calculate the average of the number, and what I'm just saying here, if the average is not known, print the average, but if the average is known, say no valid numbers to calculate the average. All right, so this is just having a lot of exceptions to ensure that I really cater for everything. And you can see internally here, I'm saying if no numbers, if there are no numbers there, raise an exception to say no numbers in the file. Otherwise, you could have another exception to saying the file does not exist, and you could have different value error. Let's do the first. The first is I don't have any file here, and I'm going to run this and we'll see how the file not found error is going to come along. The first one says that the file was not found, which is what I have here. And I also have no valid numbers to calculate the average, which is what I have here at the end if there are no files that exist. Within that, I'm just going to raise this a bit. And after that, my process end. So let me create a file, and I'm going to create this. Call it numbers.txt. The file is empty, I don't have anything in it. And so let's run this and see what is going to happen. When I run this, it's a no numbers in file. You see that this file does not exist, no longer comes up. What I have is no numbers in file, because here I'm saying if they have no numbers, throw up this exception. And finally at the end, it also throws up this one that I have when I'm calling the function to say that no valid numbers to calculate the average. Let me put in invalid numbers. I'm going to call this a car, a house, man, maybe subscribe. Of course, this should have been the first. All right, if I'm to run this, I'm going to get a different set of error. If you watch, there was no place I provided any kind of provision to catch this error. But because I put except value error, any kind of value error as E, you print that, and this is a value error. If you see that this is a value error, I entered incorrect value. And luckily for me, I provided a way to cater for that. However, I didn't put any kind of print statement on what to do, but it still printed out the particular error. And here you could see could not convert string to float. The first one was car, it could not convert that, and that was the problem. And this printed, however, because when I was calling the function, I had that provided. And let's go back here, and I'm going to put in numbers. I'll put in 1, 2, 3, 4, 55, 65. And when I come back here, I'm going to run this. And when I run this, it tells me the average is 21.6660. So this works fine because I have provided what was given. And this is just to show you how you can work around this and do a couple of things with try and except block. Please subscribe to my channel, and I hope you found this video very, very helpful. And stay tuned for subsequent videos on the 15 days of Python series. See you in my next video. Bye for now.